Modern semiconductor cleanrooms operate with absolute sterile perfection. At this scale of manufacturing, even a single microscopic speck of dust is strictly eliminated. But this entire pristine digital ecosystem depends entirely on a violently hot, primitive industrial tool, a specific glass bowl. Inside it, massive chunks of raw polysilicon are melted down. This extreme thermal process grows the highly ordered crystals that eventually become our microchips. Without this exact type of transparent vessel, the fabrication of every advanced microchip, AI processor, and solar panel on Earth would immediately halt. In late 2024, Hurricane Helene unexpectedly tore through a rural town in the Appalachian Mountains. This isolated mountain town, Spruce Pine, North Carolina, quietly produces the vast majority of the critical ultra-pure quartz required by global industry. As the physical roads and rail lines out of the valley were severed by floodwaters, an immediate panic swept through international markets. The physical foundation of our modern digital civilization is completely exposed to the elements in a single, fragile river valley. The core engineering problem comes down to heat. The Geographic process requires holding molten silicon liquid at temperatures exceeding 1400 degrees Celsius. This diagram shows what happens when engineers attempt to use a graphite crucible. At high heat, the material oxidizes, introducing microscopic carbon particles directly into the melt. Switching to alumina causes severe impurity migration, leaching elements like aluminum and iron right into the liquid silicon. Looking deep inside its atomic structure, even standard glass fails because it traps water molecules, hydroxyl groups, hidden inside its molecular lattice. At 1400 degrees, high-temperature hydrolysis takes over. These trapped water molecules violently break the strong silicon-oxygen bonds of the glass itself. This internal bond breaking causes a sudden, catastrophic drop in the glass's viscosity. The crucible bubbles, softens, and physically slumps inward mid-melt. Achieving the precise 6/9 purity required for modern semiconductor chips demands a geological miracle. Over 380 million years ago, the African tectonic plate violently collided with North America, forming the Appalachian Mountains. This specific tectonic friction occurred in an intensely dry environment, completely devoid of deep subterranean water. The absolute lack of water prevented hydroxyl groups and trace metals from ever entering the lattice of the growing pegmatite rock. Spruce pine is a frozen 380 million-year-old accident of physics, the only place on Earth yielding rock pure enough to withstand the extreme temperatures of a silicon melt. Pulling the raw, white rock from the North Carolina Earth is only the first step in a brutal global purification pipeline. The rock is subjected to extreme thermal shock. It is baked and rapidly quenched in water to physically crack open the microscopic grain boundaries. Looking at this purity tracker, the material is then bathed in highly toxic hydrofluoric acids to chemically strip out external iron and feldspar contaminants. The semi-purified sand is shipped across the Atlantic Ocean to highly specialized, high-tech chlorination facilities in Europe. A final high-temperature gas phase reaction burns away the very last trace elements, reaching an astonishing 99.999% molecular purity. It requires the coordinated, multi-continental industrial might of human engineering to finish what nature started in the mountains. Why don't rival nations simply bypass the U.S. monopoly by manufacturing synthetic quartz in a laboratory? Creating fumed silica through synthetic sol gel synthesis is currently astronomically expensive and entirely too slow for global mass production. Nations like China are actively declaring high-purity quartz a critical mineral, frantically surveying their own territories to break their reliance on American rock. This glowing crucible serves as the physical linchpin for the global economy, sustaining our mastery over artificial intelligence and nanoscale engineering. Yet the entire modern world remains hopelessly captive to a handful of dirt from a single mountain valley.